So here's going to be an interesting test. If it works, it's going to be amazing. And if it doesn't, it was worth a shot. So this little bracket right here is from my passenger side, the good side. This is from the driver's side. So as you can see, it's quite warped. What I want to do is bend this one to be as good as this one. So that way, at least I know the bracket's accurately bent, and then I'll know whether or not the alignment's coming from an issue of the chassis or frame being bent. So what I'm going to try to do is I'm going to use the Einstar Vega. I'm going to use it in HD mode, and I'm going to scan this one, which is the good one. And then what I'm going to do is create a template. That way, what I have to do is screw this one in. So the way I'm seeing it is going to be kind of like an inverted surface. So I'm going to pop the screws into the backside of my template, and it's going to be like a solid object. And then all I have to do is keep bending and warping it until it pops into the grooves of the template. That's the game plan. So going in HD mode on the Vega, I have my little rag trick for alignment. As you can see, it's just picking up quality really nicely. So it's one of those things, like over here on this project, I'm using the Einstar 1 to scan the fender, which is almost done. It looks beautiful. However, Einstar 1, not so good with little objects. Vega, HD mode, amazing. Right tool for the right job. So I'm going to use this to scan. I'll press record on the tripod, and then I'll post a clip of this. In theory, it should be pretty quick, but I'll make a full video of me doing the little quick design, as well as trying to unbend it and see if it works. Because if it does, it's going to be awesome, quick little fix with accurate precision. So I know it's hard to notice, but there it is. I think it should be good. I'll hop on the computer and process the data, but overall, very simple. Let me see if the focus is working. Yeah, it's just not focusing on this. Very simple logic. Just, yeah, we'll see. We'll see how it looks on the computer.
All right, so here's the bracket. And again, this is the passenger side. So I want it to be the driver's side because that's the one that's distorted. So the first thing I'm going to do is I'm just going to mirror it just like that. There we go. And again, for me, this is a generic kind of like, how do I warp my real bracket to make it match? So I'm going to apply the retopology modifier. Let's do like 20,000 faces, press compute, and then take a look at what that looks like. All right, so with 20,000 faces, it kind of broke right here. And that's not good enough for me. I'm going to try to change the mode to reform, 20,000, press compute, and take a look at what that looks like. Okay, so while this is better, it's actually much better. I don't know if I trust this for what I need. Like, it looks great. The scan itself is not the issue. It's my needs. So what I want is, of course, like I mentioned, the bend template. So I'm going to actually go in and manually quickly remodel this little piece. And then the other thing is the holes for the mounting to the door. I actually want these holes because I'm actually going to insert the hardware through the 3D printed element. So that way it has something to hold on to while I bend it. So just like in the past in my other videos, I'm doing freeform on surface, pick the surface. I'm going to do maybe an offset of 0.2. And then I'm going to get to modeling. So Alright, we're gonna start a new project. Bracket. Alright. And here, okay, the face is the face. That's good. Let's see if we do auto rotate too. Okay, so profile. Actually, this would be, I think, ideal. Because now it's all going to be solid, less risk of it breaking. So if we're doing this, if I do line type, see how there's this overhang? I personally, I hate overhangs. It's just they're nasty to work with. And if we're doing printing on this side, see how this is like not perfectly flat. So now let's adjust our 3D model real quick with the game plan being that, hey, we're printing it on the side. So I'm gonna select these vertices right here. Now we're just gonna do view align. So now this is going to be perfectly flat, just like that. Now I'm gonna do these as well. View align, these as well. Yeah, just so we have nice straight edges. Now, as I mentioned, we have the overhangs, and I hate overhangs. So what I'm going to do is add a edit poly modifier. And actually, instead of edit poly, I'm going to do an FFD 2x2. And then all I got to do is take these back points right here and scale them out. And as you can see, what that's doing is shifting our 3D model. Now we are quickly fixing the overhang issue. So we're going to do the same thing over here. Scale it out. Then you can manually just move one side until not create a problem. So, see how here pokes out? I don't want that, so I'm just going to move it back in just like that. Perfect. And then the center one, this one's going to have a lot of room for forgiveness just because it's in the middle of the two. So we could really shift it out. There we go. And make sure nothing's poking through the hero surface. Just like that, we fixed all of our issues, the overhangs as well as the flat face thing. So we're just going to export the bracket again, STL. All right, delete that one, import the revised version. Perfect. Auto align. And now let's take a look at what our 3D print tells us. So it still says overhang, but in all honesty, when you're looking at it the way it's printing it, it is an overhang, but it's got a lot more meat on the bone to grab onto while 3D printing. So let's do that. Again, we're doing a quick sloppy 3D print, so it's going to take 1 hour. I'm going to turn on tree supports just to see if we need them. So it says it does. It increased the print time by 20 minutes, give or take. Whatever, I don't care. I'll leave it just because I want it to be printed. So that's it. That's how you would design a bracket. So what I'm gonna do is I'm gonna 3D print this and then go back into the garage and try to undo the damage to the damaged one. And we'll see if this little quick sloppy workflow of mine functions. That's what I need. I just need a tool to unbend the thing that's bent so I don't have to spend money. So we'll do a test in real life and see if it worked.
Okay, so here is the 3D printed little reference marker, and here I screwed in the part. As you can see, for the most part, it lines up pretty nicely as far as the base goes. So now all I'm gonna do is give a shot at more or less distorting it back. So first I'm gonna try to do it by hand. There we go. And then I'm gonna use the pliers for the last little bit. See here, just like that. There we go. Wow. This is actually working out very, very well. Now, because it is a 3D print, I do hear some cracking. But for the most part, it's going back to its shape. And what I'm going to try to do is grab another set of pliers and just squeeze it on the other side. And I don't care if the 3D print breaks. But overall, we're back to where we want to be. It's not perfect, but it's definitely way better than it was. So, like that. And just like that, as you can see, only so little left in terms of distortion. So for the moment, I'm gonna put this back on the car, and then I'll be able to reference how much more I have to just gently bend it back on my own. But overall, it worked very well. Got a little damage now with the bending, but whatever. Simple as that.